Well, how's everybody doing out there? Well, welcome to day 15 of Corona Online School. So far I just wanted to say I haven't finished grading all the exams yet, but the ones I've graded have looked really good. So I'm proud of you guys for what you've been working on. And so we're moving on to a new unit today. So unit 3, which is mostly about measurement and stuff. So this one's going to be a little tricky to do not at home. So just because there's a lot of hands-on things I was hoping to work with. So like even the first practice had you guys kind of brain dumping a bunch of measurement things that you might know of, like grams and liters and stuff like that, and then kind of sharing them. So basically we're going to kind of skip practice 1 for the moment if you want to read through it just to get an idea of what my plan was for it. But instead we're just going to kind of move straight into measurement types. And so I've kind of summarized them for you here in this table. So these are sort of all the measurement types that we're thinking of. And so we've got it split up into the US system, which is basically different than everybody else in the world, which hopefully you'll realize in a little while is kind of strange because the metric system is so much nicer to work with. And then we have the metric system and how everything's broken up into categories. So like length, weight and mass, temperature, and capacity. And so right away you might be seeing that weight and mass category and kind of wondering, well, what's really the difference between them? And so it's really sort of a physics definition is what's the difference between them. So weight we think of as the force of the gravity on an object. So again, like the force of gravity and things like that. So all kinds of different forces are acting on the weight, where the mass is the amount of matter of an object. So sometimes they get used interchangeably. But these are sort of the physics definitions of what they really mean. So ultimately, like, if you think about a scale, we're talking about pounds and stuff like that. So don't get too bogged down in the differences or the of weight and mass and stuff. But all right, so a lot of this I'm going to leave for you guys to do because a lot of it's just kind of doing unit conversions and stuff like that. So if you happen to get stuck, let me know so I can give you some hints. So ultimately, what I've got is like 3 charts I want you to fill out in the beginning, which is just sort of the basic, right now we're just working with the US system, so basic units of measurement. So like 1 foot is equal to, 12 inches, 1 yard is equal to 3 feet. So go through because you're going to need these as a baseline to do kind of all the example problems. And if there's ones you don't know, look them up. I don't expect necessarily people to recognize how many miles are in a feet and stuff like that, or how many 1 mile is equal to however many feet and stuff. So feel free if there's things you don't know, Google it, look it up, so that way you can fill out this chart. And then once you do that, then we'll have a bunch of practice problems where you're actually converting, 60 inches into feet, 5 yards into feet, 8,000 pounds into tons, all kinds of different weights and units and stuff like that. And then after that, we're going to move into area. And so in this case, so we're looking at area, so that's like multiplying 2 things together. So like 1 foot squared, would be the same thing if I had 12 inches on this side, 12 inches on that side. So if I multiply them together, that would give me 144 inches squared. So again, fill these guys out, go through the area ones, and then finally, then we've got some volume ones. So again, if 1 foot cubed would be how many inches. So in this case, I'd have 12 this way, 12 that way, 12 this way. So I'd have to multiply 12 times 12 times 12 to figure out what 1 foot cubed is compared to inches cubed in this case. And then again, there's a bunch of conversions for volume for you guys to practice them with. And then after we get to there, then what we want to do is go into the metric system, which you may or may not be that familiar with. I'm not sure how much people have worked with metric and stuff like that. But if you notice on our chart at the very beginning, notice how in the metric system, there's like one of everything. Like as opposed to capacity, we've got fluid ounce, cups, pints, quarts, gallons. We've got all these different names for things. Ounces, pounds, tons, inch, foot, yard, mile, all these things. Where cells or metric, it's just one thing for each one. And so everything kind of revolves around those and then the prefixes of those. So if we go back to our little chart here for metric. So the cool thing about the metric system, and again, this is what makes it nice, is if you don't know this already, the metric system is based on the number 10, So it's a base 10 number system, which we're familiar with. We like base 10 and things like that. And so again, instead of having multiple units of measurement, all they have is just 3 units of measurement for each one. So their length is the meter, their mass or weight is the gram, and their capacity or volume is the liter. And so all they do is kind of move it around based on whether it's a bigger or smaller. So in this case, what we can do is we can add any of these prefixes to it to turn them into another thing. So like the middle would be all these generic ones. So this would be where our meter would live. This would be where our gram would live. And this is where our liter would live. And then what you can do is if you move to the right, then you're making it a smaller number by 0.1. So in this case, like this would be like the decimeter. And if you moved it over again, it's a little bit smaller. It's a centimeter. And then over here, we'd have millimeter. So all we're doing is just adding prefixes onto these. And then that actually changes our conversion and stuff like that. And so then we could go bigger. So we've got decameter, hectometer, and kilometer. So some of these are used more than others. Like you don't hear about hecto and deca as much. It does occur, but like they're definitely less frequent. Like the ones you're probably most familiar with are like the kilometer, centimeter, and the millimeter. So even though these other ones exist and it's possible, those are kind of the main ones. And then you can do all the same thing for grams. We could have decigrams, centigrams, milligrams, kilograms, all that good stuff. So you just change the prefix in the front. And then the nice thing is, you'll see after you've done the US conversion how complicated it can be because of the relationships between them. Where here, everything's kind of a piece of cake because what we're doing is we're just changing by tens every time. So we're just moving decimal points around is all we're really doing when we're doing metric conversions. And so the idea is you have to figure out where you're starting first. So let me do like practice 5 first. So in this case, we're at 6 meters, which puts me here on the chart. And so the idea is I want to move to kilometers, so I need to move 1, 2, 3 places to the left. So whenever I'm moving to the left, I'm actually going to make it into like a smaller decimal in this case. So 6 millimeters, or 6 meters, sorry, would be the same thing as, so 1, 2, 3, 0.06 kilometers. So I'm really just moving the decimal point however many places. And so if I go this way, I move the decimal to the left. If I move this way, I move the decimal to the right. So for example, if I wanted to turn 6 meters into millimeters, so again, I started here, so I'd go 1, 2, 3, but in this case, since I went to the right, then I'd add 3 decimals to the right. So in this case, 1, oops. So 1, 2, 3. So I'd get 6,000 millimeters in this case. So that's kind of the goal. I mean, you're really just, and that's why metric is so nice because, again, the conversions are super, super easy. You're just going, changing decimal places as opposed to, you'll see how complicated some of the other ones are when you actually get to it. So let's see. So what else we got? So again, so this is liter is the volume of a cube whose sides are 10 centimeters. So in that case, like you would just multiply 10 times 10 times 10. So 1 liter is the equivalent of 1,000 centimeters cube. And a kilogram is the same thing as the weight of 1 liter of water. So again, go through, fill out those practice problems. And then down here, we've got converting temperature. And so hopefully you're familiar with the US system, obviously uses Fahrenheit, which is our F in this case. And metric uses Celsius. I don't know if I just spelled that right or not. Let's see, Celsius. I feel like there should be a C in there somewhere. Let's see. Yep, there should be a C instead of an S. I knew there was a C in there somewhere. There we go. And so the goal is we're going to work on switching back and forth between these guys. So I don't know if you guys remember like what the freezing point of water in is in each system. So maybe I'll leave that to you to look up just in case. But then the goal is if you start with something in Celsius, we're going to use this formula to actually calculate what the Fahrenheit is. And if we're starting with something in Fahrenheit, we're going to use this formula to calculate what the Celsius is. So again, I'm going to leave these for you to practice. If you get messed up on them or struggle with them, let me know so I can help you out. But otherwise, I'm going to let you try those on your own. And then at this point, what I want you to do is kind of pause the video. And I've got a little Kahoot for you guys to work on to try to guess what the most reasonable metric unit of measure is. So I'll put that up on the content area so that way you guys can play the Kahoot. And then after you do that, go through practice 8, which is kind of doing the same thing, trying to get an idea of, what different sizes should look like. What would be the best metric unit. So we're not using ounces, pounds, any of that stuff. So everything should be grams, liters, and meters in this case. So there shouldn't be any kind of ounces, pounds, any of that stuff in here. Everything we're talking about is going to be metric units. And so once we're done with that, then there's some little story problems for you guys to work on. So that this case is actually going from customary US to metric. So again, we'll get to practice a little bit of that conversion. And then I think the last couple practice ones are related to velocity. So like miles per hour into different, miles per minute, miles per second, that kind of stuff. So it's a lot of unit conversions today. So again, hopefully you guys do all right on it. If you get stuck on any of them, definitely let me know so I can help get you in the right direction. Otherwise, good job, everybody, and I will talk to you tomorrow.